Hello and welcome to today's presentation, What's New in Simcenter Femap 2020. Before we talk about version 2020, we just want to talk a little bit about the direction of Simcenter Femap. The thing to look at here mostly is that Femap has been designed for 35 plus years to be dedicated to the needs of the FEA analyst. We look to maximize efficiency of FEA tasks through efficient creation of models that accurately represent real-world engineering problems and intuitive interpretation of analysis results to improve the design and performance of engineering products. How we do this is we build upon strong capabilities in Simcenter Femap. These include geometry idealization, such as mid-surfacing, powerful meshing, model creation, and interactive editing of existing mesh, in-depth support for industry standard solvers, including Simcenter Nastran, MSc Nastran, Abacus, ANSYS, and LS-DYNA, and flexible customization tools to streamline the analysis process. Something to also talk about before we get into the features and functionalities of Femap 2020 is we have gone to a 6-month release cycle. So what you're going to get is a feature release every 6 months. This is going to include database changes, UI updates, including localization, also licensing updates. These will be planned for spring and fall, so April and October. There will almost always be at least one maintenance release. This is especially going to be the case if there are any bugs that need to be fixed or a critical update needs to be applied. But you can always imagine there'll be a maintenance release regardless, simply so we can update a geometry translator or perhaps add a new version of Nastran, something of that nature. And then there may be another maintenance release if required, but again, there will not be any database, UI, or licensing updates. It'll only be bug fixes and critical updates. So again, the new features releases will be in April, October, or spring and fall. New features, expanded functionality, database changes, API expansion. This will always require licensing updates, and the localization gets updated for the new user interface for the languages that we localize into. Again, maintenance releases will be bug fixes, minor enhancements without changing the user interface. The installer now installs patches instead of full new releases on top of the existing release, and there may also be some Simcenter Nastran updates. So here's just the roadmap from Femap version 12 until now. So Femap 12 came out in October 2018. Femap 2019.1, notice that we changed the numbering scheme, came out in June 2019. There were some maintenance packs released. But what we're really going to be focused on in this presentation is the new functionality in Simcenter Femap version 2020.1, which was released in November 2019, as well as Simcenter Femap 2020.2, which was released in May 2020, and the latest maintenance pack was So our topics for today are going to be user interface and visualization, pre-processing, meshing, post-processing, solver support, performance improvements, and miscellaneous. So one of the big things we did for version 2020.1 was all of the icons in Femap were redone. The icons were redrawn with a modern style and color palette. The colors were selected to provide enhanced contrast, making selection easier. There's a consistent theme now throughout Femap, and they were designed to maximize familiarity to minimize the learning curve. So you can see the old icons on the left and the new icons on the right. For 2020.2, we took this a step further, and each of the new icons was drawn at 150% and 200% of the original size. Now, why did we did this? Because this allows us to have native support for high resolution or 4K displays. So the user interface scaling is now fully high DPI aware, and we still do have some options in the preferences. If you don't want the Femap interface to be high DPI aware, what you can do is you can disable it, but realize when you do that, Femap will always be drawn at 100% resolution. However, the text and icons can be small and hard to read. The other option is to have it handled by Windows. This means Femap is scaled by Windows, but this can result in blurry icons and text. So keep that in mind. So this is just an example. On the left, we have the high DPI aware user interface. In the middle, we have Windows native scaling. And on the right, we have no scaling. And as you can see, especially if you've used Femap on a 4K monitor or other high resolution display, that it can be a little difficult to read because the icons are very small. Some other updates to the user interface for version 2020.1 was we changed the palette button to be a color block button, which shows the current color of each entity. Also, if that entity has a pattern set along with the color itself, it will also show up in the color block. Another thing was the way digits are shown. So the control of digits displayed in the graphics window was updated for version 2020.1. So performance graphics did it one way, OGL or OpenGL graphics did it another way. So when you are actually looking at a combination of both on the screen, the two different digits could appear slightly differently. So this was all unified into one set of controls in 2020.1. So what you can do is there are two preferences on the graphics tab. One is locale, which is used to specify global options such as style, decimal zeros, and how you would like to see positive and negative numbers, as well as options. So this is used to specify a method. There are actually 4 methods, and you can choose one of the methods to be the default method. You can specify a value for round to 0, and then each method has some additional options which you can use to customize how digits are displayed. So along with the preference for the overall digits option, there's also individual digits controls in the view options for load vectors, constraints, the deformed model, contour criteria style, contour criteria legend, contour arrow options, and free body vectors. And I will say for version 2020.2, we also added beam diagrams as one of the view options that has an individual digits control. So when we go into the digits control for any particular view option, what is going to be selected by default is use preferences. So this uses the method that's set in the options preference. The 4 options are Femap Classic. This means digits are controlled in the same manner they were in older versions of Femap by specifying a number of digits and also whether you want to force an exponent for the digits when using those options. Exponent, the digits are always going to be displayed as an exponent, which allows the user to specify a number of digits and other settings for exponent style. The significant figures options, digits are displayed using a specified number of significant digits along with a maximum number of zeros before the decimal point and after the decimal point. And then there's just simply decimal places. This means digits are going to be displayed using the specified number of decimal places and are further controlled by the maximum number of digits and base exponent options. Now, the whole key to using these different methods is to set a method, then choose your other options, and then as you choose options, examples will be displayed at the top of each one of these dialog boxes, essentially showing you the way the digits are going to look with these particular options set. Once you're okay with that, you can click OK, but if you just want to see them displayed on the graphics window itself, what you can do before hitting OK is you can click Preview. You'll be able to see what those digits are going to look like in the graphics window, and then once you're satisfied, you can click OK. Display of C-bush element orientation coordinate systems is now available via the element coordinate system option in the options list for labels, entities, and color in view options. This just allows you to visualize the orientation coordinate system for coincident and non-coincident C-bush elements, and the size is controlled by the symbol size, which is set on the tools and view style category. Something we did for 2020.2 to make it a little bit easier to determine how surfaces are connected to one another is we added the curve connectivity option to the tools and view style category. So what this is going to do is it's going to override the curve color based on the surface connectivity. So if the edge of a surface is not connected to any other surface, that's considered free. If two surfaces are stitched together, that's considered manifold. When more than two surfaces come together at a particular section, or it's a T-junction, that's going to be referred to as non-manifold. And then we also have another option here for wire body, which is going to show parasol wire bodies, which cannot be made in Femap, but can be imported as another color. So when you come into the view option, you can see that there's a button, connectivity colors, which you can click, and then you can specify a color for wire body, free, manifold, and non-manifold. Once this is set up, or if you just want to use the default colors, then you can turn this on and off quickly using the view style menu on the view simple or view toolbar. So you can just toggle on curve connectivity or toggle it off to be able when you want to be looking at this particular view option. So here is an example of geometry from before the non-manifold add. So no non-manifold curves exist in this particular model. Then we do a non-manifold add. And what you can see is everywhere that's green, it has been stitched together. Everywhere that's red is free. And everywhere that is yellow is actually a non-manifold connection. So you can see that this is a T-junction. There's T-junctions here. There's T-junctions all over this body. And this just is here to allow you to know how your geometry is currently connected. We improved the renumbering commands to provide better control when choosing to offset IDs. This was actually done for the modify renumber all command and was also available in file merge, but it wasn't available in the ordinary renumbering commands. So for 2020.2, we replaced the old constant offset option and just added a new renumbering options section. So when you're set to compress, this is where you specify both a starting ID and optionally an increment. If you're set to offset to, you simply then offset to and you specify a starting ID. And if you specify offset by, what you're actually doing then is setting an ID, specifying an ID offset for your renumbering of a particular type of entity. Something else that we did was we enhanced the copy to clipboard and save to file commands for a number of dockable panes, such as the data table, connection editor, mesh point editor, function table editor, and entity editor, to copy, save data using formatted HTML. So formatted HTML also gets sent to the clipboard along with text and rich text format. And what does this do for us? It improves formatting when pasting into Office tools and allows viewing of saved files. When you've used Save to File, it allows viewing them with standard browsers. Something else new for version 2020.2 is new technology which offers the ability to transfer data from dialog boxes and panes directly to Microsoft Excel. So some examples of dialog boxes which have send to Excel commands or icons are to transfer data are the layup editor, as well as the standard entity selection dialog box on the pick menu. So that's just going to send a list of IDs directly over to Excel. So various dockable panes also have send to Excel commands or icons. Typically, these are located next to copy save icons or on a copy to clipboard menu. So if you see what we have here, we have an icon in the data table, and we have some free body information already in this data table. So the data is sent with the HTML formatting. It's organized for a clean look and feel, and it's also easy to manipulate column width and other features of the table once it's over in Excel. One more place that you're going to see it is in the charting pane. And what this does is it simultaneously transfers XY data pairs from all data series currently visible in the charting pane, and then it also sends an image of the chart that is currently being displayed in the charting pane. So you end up seeing this in Excel. And just something to remember with all of these commands, all of these send to Excel commands, is that it's going to automatically open Excel and send this data over into Excel. You do not have to open Excel first. One last item to discuss, which was added for version 2020.2, is the display of the rotation center during dynamic rotation. So what you can do is you can turn on the center option in the Include in Dynamic Rotation section found on the Graphics tab of the File Preferences dialog box. And when you do this, as you're dynamically rotating, a symbol will appear. And where that symbol is going to show up is at the center of rotation being used by the model at any time during that dynamic rotation. Okay, so we're going to move on to the pre-processing section. So for 2020.1, this was the initial release of some enhanced feature editing, which leverages Siemens synchronous technology capabilities that are found within Parasolid. So you have a couple of options for synchronous technology, and these options are really simply deciding which additional surfaces should be selected and able to move an entire feature. So there's options like offset, identical, concentric, collinear, and tangent edges. Along with this, we also added a new translate mode option. So default works just like it did before in earlier versions of Femap. Auto normal, where you just specify a distance, or interactive, where you end up specifying your options first. Then when you pick a piece of geometry, it prompts the user for a vector. So this is the same part, and we're just going to show what happens with offset detection and without offset detection. So on the upper left, this one's going to have offset detection. So what we're going to see is the entire rib is moved. Now, when we're dealing without offset detection, what we're going to see instead is that the rib is actually going to get thicker. Very similar to this, you can also rotate features around a vector. So essentially, if you just pick this one curve here, depending on what you have specified in your options, it's just going to know to grab additional surfaces that are going to move this whole feature. So what you can see is it's just going to move it over here and then move it again based on a specified angle and a rotation vector. Similar to the alignment option, which was offered for the pad operation, an alignment option was added for the washer operation of the geometry editing tool in the meshing toolbox. So this just allows you to align the split lines of the washer pattern being placed into the geometry. So automatic, the behavior is just going to work as it did in previous versions. If you're using the vector option, it's going to align the split lines to the specified vector. If you're using tangent to curve, it aligns the washer split lines to be tangent to the specified curves. And perpendicular curve is going to align the washer splits to be perpendicular to the specified curve. So you can see the various options over here, and this is just what they become after the remeshing process has been accomplished. A number of options were added to the copy, rotate, and reflect commands for version 2020.1. First, we added coordinate systems to the other entities to include. When it's enabled, all coordinate systems referenced by entities being duplicated will always be duplicated. If it's disabled, only coordinate systems which are needed to maintain the intent of the duplicated entity and any associated entities will be duplicated. We also added the assign active color option, which again, if this is enabled, the duplicated entities will be given the active color for each entity type. If it's disabled, then the duplicate entities will use the original color of each duplicated entity. And then there's also an add assign to active coordinate system. And what this is going to do, when it's enabled, the duplicated entities will reference the active coordinate system, while if it's disabled, the duplicated entities will reference the same coordinate system as the original entity. This was added on to a little bit for version 2020.2, and this was simply by changing duplicate materials to duplicate materials and layups. And what this is going to do when you're using the copy, rotate, reflect commands is for laminate and solid laminate properties, all reference layups and all materials used by reference layups will be duplicated. This is also done for laminate and solid laminate properties, which are currently assigned to surfaces as meshing attributes. When specifying tapered beam properties in Nastran, if end B does not have a specific value defined, then it gets the same value as end A. But this is only going to happen if there is a blank in the Nastran input file. So we have an option now, which is off by default, which is to write zeros at end B. So when this option is off, it's going to write a blank, meaning end B is going to get the same value as end A. But there may be cases where you actually want a 0 at end B, and that's where you would turn on this option. So what you can see in this input file is for beam property 1, we have this option turned off. So these values just go out as blanks. But then here in property 2, you can see we have this option turned on, and these properties are filled out with a value of 0 instead of being blank. Support for follower forces was added for version 2020.2. So along with follower forces, we also added support for follower moments. These are for Nastran only. And what these do are define a force or moment in terms of a magnitude and direction nodes. So you can have 2 nodes or points can be specified to define the direction of the load in terms of a vector, or 4 points which can be specified to define the direction of the load as normal to a plane. And there are both nodal and geometric follower forces that can be defined. Something from 2020.1 was the idea of being able to create multiple load sets from output using model load from output command. Now this command can be used, as it always has, by just using the default option, which is single output set, and it's going to take the loads from the selected output set and place them into the current load set. But you now also have options to create new load sets from all the selected output sets in your model, or new load sets from simply all output sets in your model at the same time. So once you've specified the from output sets option, then you're going to actually choose your load components. So say you want to create enforced displacement loads from translations, you would just pick T1, T2, and or T3 translation. So once you have that specified, it's just going to take your displacement results and it's going to turn those into enforced displacement boundary conditions. Now we do have some options depending on which type of loads you're making. So if you're making displacement loads, if you're using Nastran, these have to be constrained. So you can actually have it create the matching constraints that you're going to need for your displacement loads. And if you're doing element face loads, such as pressures, we had the ability to specify a face ID before, but this was not very useful, especially when you were trying to apply loads, say, onto a tetrahedral mesh, because all the faces can be different from element to element. So what we actually allow you to do is select multiple faces using our standard face selection dialog box when using this command. For some time now, people have always been asking if they could get a list of the entities that were on a particular layer. So what we did for 2020.1 was we enhanced the list tools layers command to be able to list all layers, empty layers only, missing layers only, or any number of selected layers. And what we now have are some additional options, such as the layer contents, so the entities on a layer. So when you have this option enabled, every entity that is on that layer is also going to be listed. We also have some options for listing any layer that is referenced by a group or referenced by a view. So if either of these are on, you're also going to see that in the listing of your layers. Something we did for tools parameters, we added monitor points and matrix input, DMIG entity types for version 2020.1, but we did not give you the ability to specify color, next ID, or increment within tools parameters. So those were added for 2020.2. Along with that, we also added an option to be able to specify the active output coordinate system from the tools parameters command. So we're going to finish off the pre-processing section by talking about a couple more tools on the tools menu. The first is tools check mesh interference command, which is used to determine if any edges of any line, planar or solid elements pass through other elements. The interference check includes cross-sections of line elements and the thicknesses of planar elements. And elements which interfere are highlighted, and the user is offered if they would like to create a group of the elements that are currently interfering. Another tool that was enhanced was the tools check sum forces command. In previous versions, this would always just perform this summation on the active load set. Now you have the ability to select which load set you want the summation to occur on, whether you want to do it on all load sets or any number of selected load sets. Just know that each load set is still going to be summed individually, not all together, as that would not make a great deal of sense. There is also now an option called send summation to data table, which will send the summation values from all of the load sets involved in the command to the data table. For many years, Femap users have asked if they would be able to calculate mass properties for any number of solid properties in their model instead of a single solid. So for 2020.2, we added those capabilities. So you can now compute an overall set of solid properties. You can think of them as calculating solid properties for an entire assembly, or simply compute properties for any number of selected individual solids. There's options for copying the listing clipboard to text, rich text, and HTML format. So when you have the send to clipboard option turned on, that's going to be done automatically. The other thing that we've added is this command used to ask you a number of questions after you were done. So now you're just going to specify them in the mesh options section, whether you want to create nodes at the center of gravity, create a representative mass element, and whether you want to link to existing mesh, either using a multi-element connection or single rigid element connection using those degrees of freedom. And finally, when using the Tools Mesh Properties command, we've now added the Send to Clipboard option in here as well, which is going to automatically send text, rich text, and HTML formats to the clipboard of the mesh properties. One other thing to mention here is we've also added support for solid laminate elements. Laminate layup thicknesses are scaled to match the length of each edge in the layup direction. Then each ply is then computed as a thin, single material brick wedge with corners at the correct top and bottom ply locations. In the meshing section, we're going to talk about tools that were added to both the meshing toolbox and to traditional meshing commands to try to improve the meshing process. In an effort to improve the idealization of geometry for version 2020.1, the feature removal tool in the meshing toolbox was updated to perform more robust blend removal. So it now follows this process. First, it attempts to remove all blends at one time. If that fails, it then tries to remove chains of blends, or blends that are basically confined or next to one another. So then it tries to go remove these chains of blends or blend chains one at a time. It then makes a second pass through the blend chains if required, because sometimes a blend chain can be removed after other blends in the model have already been removed. Now this can take a longer time, but it does a much better job. And also what was done for 2020.1 is the removal of blends at stepped locations, which you can see here, was also improved greatly. To make blend removal even more robust for version 2020.2, a new preview option was added to the feature removal tool when feature type is set to blends. So when this option is on, all of the surfaces that the tool plans to remove will be highlighted in the screen, and the standard entity selection dialog box for surfaces will appear. At this point, the user can add or remove specific blends or other surfaces to attempt to remove with this tool. One other thing to note is that this can also be used with or without a limit size for blends. Now what's nice about this is here you can see a number of blends have been highlighted. If you look in the entity selection dialog box at the bottom, a few surfaces have been added and removed, and then I can simply just click the highlight button again. And once I have these all selected properly, I can hit OK, and then the operation can be completed. Something else done in the meshing toolbox for version 2020.2 was the addition of an option to the extend operation, which is called surface replace face. So this option was added to extend faces of a solid up to a selected surface, remove fillets that have failed from blend removal, and or raise or retract surfaces to a main solid. And in this case, what you're really doing is removing features. And again, the surface replace face option has now been added to a new section called geometry type and can be found underneath curve on surface. So what we have here is the original geometry. You select a surface to extend to, or destination surface, as I like to call it. Then you choose which surfaces to extend to that surface. And in this case, you'll see that those surfaces were essentially extended or replaced by the destination face, thereby removing the blends. Here we have a part that has some text inscribed into the part. So here we would choose a destination surface or surface to extend to. We would choose the bottom of each letter, and once we click OK, you can see that those letters have been removed from the part. One final way to use this tool is you can see that the side surfaces of these two solids do not line up properly. So what we can do is we can pick the bottom surface as the surface to extend to. Then we can pick a surface on the diagonal solid coming in to the junction. And now you can see that the surface on the diagonal part has been moved out to meet the surface on the bottom part. Another thing we did for version 2020.2 was update the various commands on the mesh editing menu to make them more consistent with one another. These commands, mesh editing interactive, mesh editing split, mesh editing element refine, and mesh editing edge split, all behaved a little differently, mostly because they were added to Femap at different times in completely different versions, and they just were not very consistent. As of 2020.2, these commands will all now update nodal constraints and nodal permanent constraints, update loads on faces, corner pressures on edges, and distributed line loads, update regions, so any underlying nodal or elemental region that gets changed will be updated. It will also update tapered beam shapes, beam offsets, plate thickness, and material direction. Groups will be updated, and so will geometric associativity. For version 2019.1, we actually added a new method to the mesh sweep commands, which is called along element edges. And what along element edges would do was take the elements or element faces that were about to be swept and move them and morph them potentially along existing element edges. For 2020.1, we added two new options to this command. So the first was limit sweep to visual mesh. So as you can see, we're going to take these elements and we're going to sweep them along these existing elements. Now, when all of these elements are visible, the sweep happens where it actually sweeps along this side differently than sweeps along this side. If we turn on the limit sweep to visible mesh, then we can see as the sweep occurs, it's only going to sweep it along this peach colored mesh or this mesh over here and be all consistent. And then you can actually see that it doesn't match on this side, but that was the intention. Now the other option that we added was merge nodes to adjacent element, and this simply controls if the new swept elements are automatically connected or not to the sweep path mesh, which may or may not be the intention. Here is another example of commands that were updated over multiple versions. Prior to version 12, mesh edge members was a single command used to create line elements on edges or planar elements on element faces. As of version 12, this became two different commands on the mesh edge skin elements menu, line elements on edges, and planar elements on faces. For version 2020.1, the commands were improved to allow the user to select edges or faces instead of elements then nodes for the locations of the elements to create. Because we're now selecting element edges or faces, there are some very nice ways to select these, including model-free faces and model-free edges. And when you're using the line elements on edges command, there is now an option at the end of the command to allow you to offset the line element edge mesh that has been created using the same options that are available in modify update elements line element offsets. Prior to version 2020.1, the mesh geometry solids command had three options for merging the nodes of the elements created during the command, and they were off, new nodes, or all nodes. What was missing was an option to merge any newly created nodes on the solids into existing nodes that were already in the model. So what we added was the option 2 into model and simply moved all nodes to be number 3 in the drop-down list. So what does this mean for you? If you have these two solids already meshed, and then you mesh these two solids with this option set to 0 off, then no nodes are merged. If you use 1, then only the nodes on the newly created nodes are merged. If you use option number 2, then the nodes from the two solids we meshed with the command will be merged into the already existing nodes in the model. And if you were to use 3 all nodes, then all of the nodes in the model would be merged. And that doesn't even include just these 4 solids. If there were other solids in the model, then all nodes would be merged by using the option 3, all nodes. The final improvement to a meshing command we're going to talk about was implemented in version 2020.1, and this was to the mesh connect rigid command. Now, what we did here was we added 2 options. One was allow target to be mapped to multiple source nodes. We did this because in certain models, this can aid in reducing collinear rigid elements without the need for creating additional degrees of freedom, and can provide better load distribution. The other option we added was minimum targets per source, which again can aid in load distribution and prevent any target nodes from being overly influenced by a single source node. So what did this allow you to do? If you had this particular geometry, the original mesh, which is still available, you just simply would not turn on the allow target to be mapped to multiple source node option. You would get these elements in red. With new options, including the one I just discussed, that's where you could get these green elements on this same geometry. We will now discuss new features and enhancements to existing functionality for post-processing that were implemented in Femap 2020.1 and 2020.2. One of the first things to know about version 2020.1 is there are new output vector ID ranges for elemental output. If we look on the left, we're going to see the pre-2020.1 vector ID ranges. What you can see is that plate top were in the 7,000 range and plate bottom were in the 7,400 range. If there were plate middle vectors, they would be in the 7,200 range. Moving forward, 2020.1 and above, you can now see that the plate top vectors are still in the 7,000 range, but the plate bottom vectors are now in the 9,000 range. And if there were any middle output vectors, they would be in the 8,000 range. Building upon the automatically connect to Excel functionality added to version 2020.2, we have the list output results to Excel command. Much like the other features that now automatically communicate with Excel, this command allows you to automatically open Excel and transfer a variety of results very quickly. Much like the list output results to data table command, this command allows you to take advantage row and column order, and if you would like to see the results in an alternate column order. One thing that this one offers, which is a little different, is the ability to do automatic formatting, which I'll get into a little bit later. Just like results to data table, there is the ability to transform the results, but unlike that command, this command allows you to transfer both nodal and or elemental results at the same time. So the process is use the command, set your report style, set any transforms if you like them, and once you click OK, then you'll be prompted to choose output sets and output vectors. Now, when you do have the formatting option turned on, each worksheet in Excel, we'll include column filters for all columns, frozen row headings, and frozen ID column. So basically the headings at the top will stay there as you scroll up and down, and the ID column on the left will remain there as you scroll right and left. And nodal and elemental results will be organized onto two different sheets. One piece of visual post-processing functionality that was added for V2020.1 was the idea of doing a capped isosurface. So when you're doing a dynamic isosurface without a cap, what it's showing you is areas in the model which have the same contour value. So it's only showing you bands of color. When you have the cap turned on, we have a positive cap turned on, this shows the isosurface of the value and all values above your specified isosurface value. This is very useful for topology optimization results. If you've chosen to do a negative cap, that's showing an isosurface below of the value and all other values below the specified value. Version 2020.2 added support to display a number of different output types for static aeroelasticity analysis, solution 144 in Nastran. Now, be sure to know that these results are only available in the FO6 file, not the OP2 or XDB file. So the first one of these results, which for the first time are able to be shown on the aero mesh instead of the structural mesh itself, is aero pressures. Another one is the ability to show aero coefficients. And a third is the ability to show aero forces, again, on the aero mesh, not on the structural mesh itself. Something else added for version 2020.1, actually in Maintenance Pack 2, not the original release, was support for shell thickness output, requested by the shell thick command from Simcenter Nastran Solution 402, the multi-step nonlinear kinematics solution sequence. For 2020.2, we expanded upon this by being able to read plastic strain output from Simcenter Nastran Solutions 401 and 402. And we also added support for progressive ply failure results, automatically requested by PF results, which are attained from Solution 401 and Solution 402. Now, the failure results include damage status, damage values, damage energy, and crack density. And here we have some examples of damage energy. And here we have some examples of damage value. As I mentioned before, Femap will place results in the middle of plate elements in the 8000 range in version 2020.1 and above. We had an API script to calculate these values in many versions of Femap, but now for version 2020.2, we've actually added an option to the results tab of file preferences, which is compute averaged mid-stress strain. So it's a simple average of top and bottom results. It includes computation of invariance from averaged mid-values of the component stresses. It's supported for results which are either read into the database or attached. And there's one caveat in that it is not supported for complex results. Stress linearization is a concept based on the American Society of Mechanical Engineering's Boiler and Pressure Vessel Code, 2007 section, etc., etc. And what it does is it calculates a linearized membrane, linearized bending, and peak stresses along a stress classification line. So we had an API add-on tool which you could install in Femap and then could be launched within Femap itself. But now the tool has been added natively to Femap. It is important to understand the principles of stress linearization, as choice of the SCL, the stress classification line, is critical, and the user should be familiar with the criteria for proper SCL definition as defined in the ASME standard. Stress tensors are extracted from FEA results and transformed to be aligned to the stress classification line, and then the linearized membrane stress tensor components are the average of each along the SCL, and linearized bending stress tensor only includes hoop and normal axial stress and hoop normal shear stress. The process for using this command in Femap is to choose an output set, choose whether linear or nonlinear results for the stress tensor should be used. This is only if both linear and nonlinear results both exist in the output set. You choose an element type for stress data from shell, solid, or axisymmetric. Choose whether you want to use von Mises or Tresca stress. Then you pick two nodes at the beginning and the end of the stress classification line, then press the Calculate button. Stress linearization results are typically shown as a graph and nothing else. There's a chart showing the actual stress along the SCL, calculated membrane, bending, membrane plus bending, and maximum membrane plus bending are all shown in the graph at the same time. There is a copy to clipboard option, and the exact data values can also be copied from the Femap chart using a different command in the embedded chart control. Just a few notes: full component bending option allows you to process the linearization with all components of the stress tensor considered for the bending stress calculations. And for the Tresca stress criteria, this calculates a Tresca failure criterion stress value, which is based on the maximum shear stress. The Tresca stress is calculated by the tool. The Tresca stress calculated by the tool is 2 times maximum shear. Finally, this is just an example, the stress classification line from one node to another node. As you can see, it will be drawn on the model. This just happens to be a model of axisymmetric elements. And then you can see after you press calculate that your output has been added to the embedded chart control in the tool itself. Moving on to some support for various solvers that was added to 2020.1 and 2020.2, we're first going to start with various Nastran solvers. So the first thing to talk about is that large IDs have been added. And when we're talking about large IDs, we're talking about IDs above 99,999,999. These became available in both MSC and Simcenter Nastran solvers some time ago, and now they are supported by Femap. Another thing that we did was when we're writing the global cylindrical and global spherical coordinate systems in Nastran large field format, the continuation entries are now properly designated, so Femap knows these are global coordinate systems, thus does not read them in again because they already exist within Femap. Something else now supported for multiple Nastran solvers as of version 2020.1 are monitor points. Specifically, we're talking about the mon.1 and mon.3 entries. What these do is print labeled output for integrated loads on structural and aerodynamic models. They can be defined via a dialog box within Femap, and you can create or edit these via the model info tree menu commands, and there's also full access to them through the Femap API. There's also a graphical representation of the monitor point drawn at the summation point for visualization purposes. Just to show what is supported for Simcenter Nastran, for mon.1, it's it supports solution 144, which is static air elasticity, and for MON point 3, solution 101 and 103, which are linear static and modes are supported. As you can see, there is quite a few more solution sequences supported for MSc Nastran, and just something else to note is that monitor points now appear in a simulation objects branch of the model info tree, and within here you can manage, edit, list, delete, renumber, or change the color or layer of any number of monitor points through the tree. Also for 2020.1, we added read-write support for the DMIG bulk data entry, which is direct matrix input at grid. So we can choose to either internalize DMIGs as Femap matrix input entities or leave them externalized and attached to a punch file. You can view header data, preview column data in the data table, edit matrix entities via the API only, or you can specify combinations, scale factors, and select in the analysis set. So essentially you have this dialog box in the middle, which allows you to specify a title and some other information and just review information in general, a button down here to send the information to Excel, and then within the analysis set itself, the analysis set manager itself, you can choose which of these you would like to use for your G-type matrices and or your P-type matrices. Finally, another entity type that was added in version 2020.2 for multiple Nastran solvers was support for the general element, or the GenL as it's known. It allows you to define a substructure in terms of empirically determined structural data. There is a table interface for defining deflection influence or stiffness matrices information, and then there is a graphical representation drawn that represents the connected degrees of freedom to the constrained degrees of freedom. Solution 200 support was expanded in 2020.1, and it now allows you to choose frequency harmonic response as an analysis type for a solution 200 design optimization, and it's a similar setup to both statics and modal analysis. Another thing that was then added in version 2020.2, mostly for nonlinear analysis, was support for follower forces and follower moments. So when two nodes or points are specified to define a direction of the load in terms of a vector, that writes a force 1 or a moment 1. When four nodes, points are specified to define a direction normal to a plane, that writes a force 2 or moment 2. And once again, just to reiterate, these are typically used by solution 106, solution 401, and solution 402 for analysis which includes large deformation. Support for solution 401 and 402 in Simcenter Nastran was upgraded for 2020.2 by adding new nonlinear control options for both solution sequences. So there are global parameters for solution 402. You can specify a version for parameter defaults, again for solution 402. And there's the ability to disable specific categories of mechanical loads for solution 401. There's also a number of options added for restart capabilities from the last converged time step. So some other things for solution 401 only, we added various options to solution parameters, stiffness parameters, convergence parameters, and time integration sections of the solution and convergence dialog box. For solution 402 only, added options to the global parameters and advanced parameters section of the multi-step global control options dialog box, added options and made various other updates to the multi-step control options dialog. Added options to various sections and updated layout of the solution and convergence dialog box, and added support to write requests to recover elastic strain output at grid points, which was done for 2020.1 maintenance pack 2. Solution 401 and 402 support was also upgraded for 2020.2. We added new nonlinear contact and control parameters for solution 402, added two new function types, true stress versus strain and true stress versus plastic strain, specifically for solution 402. And we also added a new option to consider thickness and the Z offset for shell elements involved in contact in solution 402. In addition, we added support for modeling the progressive ply failure for solid laminates. This is done through the MAT DMG or MAT damage card, as it's known. So new material types in the other type section to specify unidirectional fiber reinforced ply damage model or the enhanced unidirectional ply damage model. We also added a new function type, which is only used with property 512 and property 13, the UD or the EUD ply failure materials, which is shear damage versus thermodynamic force. And what these are used to do is compute the damage values, energy, status, and crack density to predict failure. And this allows you to do the post-processing of the progressive ply failure results I showed in the previous section. A few more advanced options were added to the ANSYS translator in the Analysis Set Manager for versions 2020.1 and 2020.2. So first, in 2020.1, we added model control, which is basically allowing you to use a group in your model to only write a portion of the model out to the input file. This was expanded in 2020.2 to include everything in this model control section, which includes the options to skip the coordinate systems, skip nodes, materials, properties, and skip elements. In addition, there's also the ability to skip groups, which allows the user to skip writing the E cell, N cell, and CM entries during export. And added a skip misc, so skip miscellaneous, which allows the user to skip view settings, preprocessor commands, solution settings, and along with the solve and finish commands. We also changed skip beam bar cross sections to simply be skip shapes to save room in the dialog box. Along with that, we also added the result control section to select the file compression level for ANSYS results files. As of ANSYS 19.3, the results files are compressed automatically. So we now have the option of whether we want no compression or what they call version 1 compression. But of course, because this compression now occurs automatically, we also added the ability to read output data contained in ANSYS results files, which are version 1 compression, again, which is the ANSYS default. We also added manual control sections to a number of different ANSYS dialog boxes, including command and model control, load step, time step options, modal analysis options, harmonic analysis options, random vibration analysis options, buckling options, nonlinear options, and output requests. We also added enhanced support for random response analysis in ANSYS. This happened in version 2020.1. So in 2019.1, only one excitation, so one PSD is supported. For 2020.1, we now have multiple excitations, including self-PSD and cross-correlation PSD functions are both supported. It now has the same look and feel as Nastran analysis, and there is a limitation, though, in that spectrum results have to be processed in ANSYS. We also added support for variable thickness shell elements in version 2020.1. And some miscellaneous things we did for ANSYS in the same version was more complete support of ANSYS element selection and node selection, the E cell and N cell commands. These allow for correct interpretation of these commonly used ANSYS commands when reading ANSYS input files. ANSYS selections also become Femap groups, which can be very handy. The Femap groups are written as ANSYS components. We added support for more constraints and loads using ANSYS element and node components. That's now supported correctly. Also, all features in the ANSYS translator are that the ANSYS translator supports, both writing from Femap to ANSYS and also reading from the ANSYS input file into Femap.
Continuing with the solver support section, we're going to talk about what was added to LS-DYNA. So for version 2020.1, much like ANSYS, we added the portion of model to write option, which will just write out a portion of the model specified by a group in Femap out to the input file. This also was expanded for 2020.2, and again, everything in the model control section. So we added the ability to skip coordinate systems, nodes, materials, properties, and elements. Again, just like we did for ANSYS. We added the ability to skip groups, which allows the user to skip writing star.set entries during export. Added the ability to skip functions, which allows the user to skip writing functions, which are star-defined curve entries during export. And also added a skip misc or skip miscellaneous, which allows the user to skip comments starting with the $, star keyword, star title with corresponding title, star control termination with corresponding value, star database binary D3 plot with corresponding value, and star end, along with other entries during export. Again, much like we did for ANSYS, we also added support for variable thickness shell elements for LS-DYNA in version 2020.1. And what this is going to do is write you the star element shell thickness entry. To finish off the solver support section, we're going to talk about Abacus. So there were things done for both model import and model export in 2020.1. For model import, we no longer support import of fixed field format files because they are no longer compatible with the solver. We added import of star connector section types, bushing and beam elements. So bushing elements import as C-bush elements with appropriate properties. Beam elements import as C-bush elements with very large stiffnesses in all directions. We can now import and retain contact pair, surface interaction, and surface definition names. We added support for deload trvec to create directional pressure loads, and added import support for off-axis rotary inertia values for mass elements. In terms of export from Abacus, we now export the deload trvec from Femap, which are, again, directed pressure loads. The maximum entity ID is now 9 digits. It will produce an error if the ID is larger. Contact surface names when the surface is untitled is now 10 based instead of using letters. So example region 11 surface will now be CS11 or 11 instead of CSB. And we use connection entity titles as Abacus names. For 2020.2, we added a preference called preserve load boundary condition sets for Abacus. When enabled, this causes imported loads and boundary conditions which reference a set entity in the Abacus file to create a load definition or constraint definition within Femap. And then we also added support to write all supported load constraint types that are contained in a load constraint definition as a set entry in the Abacus input file, if requested by enabling the write all groups as set option in the Abacus Model Options dialog box. The next section, we are going to talk about performance improvements. All of these improvements were implemented in Femap 2020.2. The first one we're going to talk about is the connect automatic command. We made a 3 to 5 times improvement in models with a large number of connections. Something else we did was with geometry, copy, rotate, reflect, and the commands on the mesh, copy, rotate, reflect menu, and the move commands. So significant improvements have been made to both the copy move phase of the commands and the redrawing phase especially. Most noticeably was improvement in large models when copying small portions of the model, giving you potentially a 40 times speed improvement. Length-based operations on curve, such as mesh sizing, curve-based sizing. We found some nice ways to do this with the Parasolid code. So the along curve, length along, and midpoint methods all got faster and more accurate, and mesh sizing got 2 to 3 times faster on large models.
Another thing is commands which can be aborted. Many of the checking and listing commands in Femap can be aborted while doing computations or listing results. The reason that some of these commands took a lot longer than they should have was because we were checking for an abort every time through the loop. We just simply check for an abort less during the command. So this can give you anywhere between a 2 to 100 times speed improvement for these commands. And it's only going to take a little bit longer to abort these commands if that's what you choose. And the largest improvements are in the tools check and tools mass properties commands. The output process commands, so model output process, specifically envelope linear combinations and RSS combinations, all received a 30% plus speed improvement. Nastran model read, which was already rather fast, got an almost 2 times speed improvement when importing large input files. And when the final thing is the reading of ANSYS results, the RST file. We saw a 2 to 3 times improvement when reading results from the non-compressed RST file. So creating entities in an already existing model could be relatively slow in previous versions of Femap. So what we did to improve this, especially when you're using performance graphics or PG on this slide, is we minimize free face evaluation and we actually minimize full graphics regenerations. So we only do partial regenerations of the graphics. Essentially, we're just trying to only regenerate the portions of the graphics that need to be regenerated to show that a new entity has been created. For example, if you're creating a single entity, in this case a rigid element, in this model that has 3.3 million 10-noded tetrahedral elements, this took 29 seconds in 2020.1, but now takes 0.3 seconds in 2020.2, so almost a 95 times speed improvement. Now, what you will see also, because of the same work that we did for creation of entities, is you'll see some improvement to copy an entity in large models. It just won't be as significant as during the creation process. We added some preferences to the graphics tab, which also provide performance improvements specifically related to graphics. We added a Control-G group evaluate option. So every time someone uses the group operations evaluate command, we will automatically perform a Windows regenerate after the evaluate has been done. This helps when creating entities into groups which are currently displayed. We also added a disable abort option to the graphics tab. So this basically disables checking for aborts completely. Now, because of the work that we did, just checking the loops of aborted commands, you're probably not going to see a whole lot of difference, but it may be helpful. We made max VBO megabytes and min VBO bytes. These weren't available when you turned on the best possible option, but now you can set these again, and these may be helpful to speed up your graphics performance. And just last thing that doesn't have to do with the preferences is just we improved performance of generating thumbnails that are shown with model files in Windows Explorer. So for a large model, it went from taking around 30 seconds to being around 10 seconds. These next 2 slides are actually going to cover performance improvements which were implemented for 2020.2 Maintenance Pack 1. This is just the kind of thing that you might see other than bug fixes in a maintenance pack moving forward. So for model load expand command, we significantly improved the performance of expanding geometric loads on large models, especially surface-based loads on models meshed with solid elements. Now, this also happened to improve other commands that need to expand loads, such as tools check some forces. If you use the model analysis command, then press the preview button, or basically any command that writes an analysis input file also got the speed improvement. Because of a customer request, we looked into tools check coincident points. We significantly improved the performance of merging points. Our example, the model contained 200,000 plus points and 220,000 plus curves. That formerly took over 16 minutes to merge and now takes under 4 seconds, so a 240 times speed improvement. We also significantly improved performance of converting between nodal and elemental results on large models. This improves contour and criteria plots, where the requested type of plot differs from the type of output being displayed. This also improves the performance of the convert operation when using the model output process command. And the last thing that we did was in the view advanced post stress linearization command, we now use a better algorithm to determine which elements are along the stress classification line. So again, this was brand new functionality we added to 2020.2, and then we were already able to update it and improve the performance in the first maintenance pack. Finally, we're going to talk about some miscellaneous improvements and additions that have been made in 2020.1 and 2020.2. The first thing we're going to talk about is the API programming pane. So we added auto completion favorites. So when you're calling a method that contains arguments that are chosen from a number of available options, these options have traditionally been shown in a drop-down list as you type. Now, as you choose an option for the first time, it will move to the top of the list and be shown with an asterisk to indicate that it is now a favorite. When you come to another argument of the same type, your favorites will now be easier to find at the top of the list, and you will not have to search the entire list to find them every time. And just realize that these favorites persist for an entire session, but once you close Femap, the favorites go away, and you'll just have to establish new favorites or those same favorites again in a new session of Femap. We also added symbol highlighting, so as you click on a parameter, method, or other symbol in an API script, the user interface will highlight all occurrences of that item throughout the script, making it easier to see where that item is referenced. In addition, a second scroll bar will appear in the upper right portion of the window. This scroll bar can be used to jump to the next or previous occurrence of the item in the script very easily. And one final thing was we made the watch window the default tab that is displayed when you're debugging. Previously, it was a different one of those windows up top, so now it's the watch window, because that's the one that everybody uses when debugging. We mentioned this earlier in the post-processing section that for 2020.1, elemental output got new output vector ID ranges. Now, this is going to have some implications in the API. So conversion of the output vector IDs in models stored in older versions of Femap is handled automatically during the neutral file conversion when the model is brought forward into a newer version of Femap. Existing API scripts will continue to run with the pre-2020.1 output vector IDs, but should be updated as soon as possible. New V2 API methods and properties found on various API objects have been added to operate on the new output vector IDs. In addition, API calls have been added to convert old vector IDs to new and vice versa. We also added API calls to specifically output by new predefined quantities such as top von Mises stress instead of having to know a specific vector ID, which would prevent needing to recode APIs in the future should the vector IDs change again. So, yes, the vector IDs have changed. Old APIs will work fine. When asking for ID 7033 and in a legacy output request, it will automatically get mapped to the new IDs. So going forward, don't use output vector IDs. Instead, use the lookup functions in the FE results ID query object. And in this case, what you could do is use the FE results ID query object to automatically return you the IDs for top von Mises and bottom von Mises stress. Again, there's also two ways to get the output vector ID. So you use the results ID query object, or you can use it in line with the FE results object or the results browsing object. There's also some ways to check for old code. So old FE output requests will get warnings during when you run a script. And if you right-click in the API programming window and choose Scan for deprecated code, it will show you any of the calls that have been deprecated. This is just one more thing to know about, and that's when you're creating your own output data, you must start using the results browsing object, or the RBO. The RBO is like a spreadsheet. You fill columns with existing output data from Femap. You can then create your own columns, which you then can place your calculated data. Then what you can do is you can save the new columns back to Femap as output. So you can actually take a column from the results browser object and then automatically have that create an output vector, a fully populated output vector within Femap for you. Finally, two last things to talk about, and that's the ability for API developers to now control multiple Femap sessions simultaneously. This was added for version 2020.2. This includes Excel VBA developers. It's only forward compatible, so this is only going to work with Femap versions 2020.2 and above. And essentially, what we give you is we gave you two new calls, FE app running application info and FE app get running application. And you can now code that into a tool that you can use to either automatically or manually select which instance of Femap you want to be connected to for your API commands. Last thing to talk about is the merge tool object. So the file merge command was not in the API, but now it is for version 2020.2. So we've added a merge tool object. It is very similar to the copy tool and move tool object, but exposes the capabilities of the file merge command instead. It gives you the ability to select from model, methods to toggle individual groups of entities, or just individual entities of what types to get. There's add related and add associated options. There's unique methods for orientation transform options. There's properties to specify the various options that are in the file merge command. And there's actually the ability to create patterns of merged entities, which is actually not within the UI, and that's just the API programming window showing that. And that's it. So now it's time for the question and answer. Thank you for your time.